In this video, we are going to discuss about the magnetic moment of complexes. We go for spin-only magnetic moment. This is very often asked in CSR exam. The concept, it is very simple. Whatever you have to remember, it is very simple. So it is a very simple formula. That is nothing but magnetic moment spin only. It is given by a formula like this: n plus 2 square root. Also, it can be given by another formula, that is 4s s plus 1, which is equivalent to 2. I have taken that out, s into s plus 1. So these two formulas are most common, and generally students follow this: square root of n into n plus 2. What is n? The number of unpaired electron. If all the electrons are paired, then it will not have magnetic moment. Only the unpaired electron contributes to magnetic moment. So you should able to predict the number of unpaired electron. What is S? It is total spin. So this can be calculated from this formula: number of unpaired electron multiplied by half. So each unpaired electron contributes half spin. So if say there are 5 unpaired electron, 5 multiplied by 1 by 2, so 5 by 2. So now if you notice, whether you follow this formula or this one, it doesn't matter. In both cases, you should find out the number of unpaired electron. If you know the number of unpaired electron, then it is very easy to predict. How to find out the number of unpaired electron in a complex? So this is somewhat difficult, but if you practice, you will get this very easily. In order to find out the unpaired electron, first you should know the electronic configuration. It may be neutral atom or cation. Whatever it may be, you should be able to predict the electronic configuration of that metal atom. So for that, if you know the atomic number, it will be easy. Second one, you should know whether it is tetrahedral or octahedral. So this can be easily identified from the number of ligands attached to the metal atom, that is coordination number. If the coordination number is 4, then you can say it is tetrahedral. If it is 6, it is octahedral. So that is coordination number. Based on that, easily you can predict. The second one, you should know whether it is high spin or low spin complex. In other words, I can say whether the ligand, whatever is attached to the metal atom, central metal atom, whether it is weak or strong. If it is weak, then the compound will be high spin compound. If it is strong, it is low spin compound. Further, this can be found out from spectrochemical series. So if you know this, you can find out the number of unpaired electron and you can solve very easily. Here I have mentioned that you should know whether the field is tetrahedral or octahedral. The reason is, under the influence of the ligand, the d orbital, they are getting splitted into T2G and EG or T2E. When you go for octahedral field, T2G will be filled first, then EG. But when you go for tetrahedral, E will be filled first, then T2. So you should know whether it is tetrahedral or octahedral. I go for some problem. Consider this titanium 3+. This is very well known complex. Here the titanium, it is in 3+ oxidation state. So as soon as I say this, I can say it is in 3+ oxidation state. That means since the number of electron in titanium, it is 4. Since it is 3+, 3 I remove, so it will be like this. So this is 3D and 4s. So it is very simple for me since it is only 1 electron. So there is only one unpaired electron in this. So I have to substitute in the formula. So that is n into n plus 2. What I get is 1 plus 2, that is 3. If you calculate, this value will be around 1.7 something. So what is the number of unpaired electron? That much value you will get. Say there are 5 unpaired electron, this value will be around 5.8 or 5.9. I go for another complex, nickel tetracarbonate. You may know this compound, it is tetrahedral in shape. So there are 4, so it is tetrahedral. I go for the electronic configuration. Nickel is in 0 oxidation state. So the electrons, the electronic configuration is like this. In this there will be 2. Here there will be 8 electrons. So this is the electronic configuration. You should know the electronic configuration. There is no other option. Now look at this. This is the electronic configuration. It is tetrahedral field. When this d orbital is splitted into 2, it will be like this. This is E and this is T2. You should not use G. There won't be gerade in the tetrahedral field. So use E and T2. Now for E it is doubly degenerate. This one it is triply degenerate. Now I have to place the 8 electrons in this. Now the number of unpaired electron, it is 2. So I go for the formula 2 into 2 plus 2. So what I get is 2 plus 4, 8. So if you calculate, it won't be 3. If it is 9, then you will get 3. Since it is only 8, it will be around 2.8 or 2.9. So again you can see this, the number of unpaired electron and the whole number, they are same. Generally students, what they do, they go as such. They will go for the electronic configuration like this and they count the number of unpaired electron. Here it is 2 and they calculate. That is wrong approach. In this case, even if you calculate as such, it will be same. But in other cases, it may be problematic because the pairing of electron, filling of the orbital in the E and T2 or T2G or EG level, that is very important to find out the number of unpaired electron. I go for a compound with a D5 configuration. Say it is manganese 2 plus and there are Ligon 6 numbers. So it is octahedral field. Mn is in +2 oxidation state. That means the d orbital will be like this. If you consider as such, you will wrongly predict that there are 5 unpaired electrons. Now, if it is weak field, the ligand, whatever I have attached, it is Mn H2O 6 say 2 plus. It is only water. It is weak ligand. So what we get is, say this is T2G and this is Eg orbital. The electrons will be filled like this. So the number of unpaired electron, it is 5. So whatever you have got here and here, it is same. Instead of this, if you have been given this compound, again it is in Mn is in +2 oxidation state, but the ligand, it is strong ligand. In this case, what happens? This is T2G and Eg. First electrons are filled like this, singly it is filled. Now the next fourth electron, it has two possibilities. It can go to the Eg level or it may be paired up here. Since the energy difference is high in the case of strong ligand, it prefers to pair. So what we get is this configuration. So there is only one unpaired electron. So that is why I told you should not predict from the electronic configuration as such. After that, you have to calculate whether it is octahedral field or tetrahedral field, whether it is strong ligand or weak ligand. Based on that, you have to fill the orbital. Then you have to find out how many unpaired electrons are there.